Okay, so can you see the screen? Virtual blackboard.
Yes.
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 So now after resistance, we will be discussing the capacitance of PN junction diode. So every element has some resistance, capacitance, and inductance. Even our human body exhibits some resistance. So the value of resistance of human skin is around 20 kilo ohm, 20 to 50 kilo ohm per square centimeter, and that is resistance per unit area. And this is the value for dry skin. If your skin is wet or moist, so the value becomes zero point 0.5 to 0.1, around 1 kilo ohm per centimeter square. So also your human body also have exhibits some capacitance, and that is why you are able to use the capacitive touch discrete technology. So the value is around like 100 to 200 picofarad. So diode also exhibits some capacitance. Okay, so this resistance, capacitance, and inductance, we try to model each and every component. If we are solving, if we are designing an electronic circuit, so our aim is to convert each and every element in the form of resistance, capacitance, and inductance. So mostly inductance is ignored. We use resistance and capacitance primarily, and now it's turn to discuss this capacitance. Okay, so because of this capacitance, every electronic element is frequency sensitive. Okay, and the characteristics of devices changes with frequency, because the reactance, suppose the capacitance is C, so we define reactance xc for the capacitor. If this is a parallel plate capacitor or any kind of capacitor with a value C, so reactance is defined by the formula 1 upon 2 pi fc. So here f is the frequency of the signal applied to it. Okay, so if the DC signal, for DC signal f is 0, DC signal is a straight line, no frequency. Frequency of DC signal is 0. So f is 0. So reactance value will be infinite. Okay, so that's why when we were discussing the this up till now we were talking about DC, external DC voltage source. Okay, so for DC voltage source, if you have applied this DC voltage source, so frequency of this DC voltage source will be 0 and reactance will be infinite. Infinite reactance means a kind of open circuit. Okay, kind of open circuit. So open circuit means it does not exist. Okay, it is not the part of the circuit, so that's why we were not considering the capacitance till now. Okay, now just for an example, take this circuit. So this is a voltage source operating at frequency f. Okay, and this we have resistance R1 and R2 and
सर
हाँ जी,
सर
हाँ
सर
जी, हाँ जी, हाँ जी, बोलो।
सर नोट्स अवेलेबल है?
हाँ, अपडेटेड है ये, यहाँ तक अब ये पूरे अवेलेबल है। गूगल
LMS
ड्राइव
पे
लिंक पे कल तक के लेक्चर्स अपडेटेड है, मैं विद इन 15 मिनट्स अपलोड कर देता हूँ, और ये नोट्स ऑलरेडी अवेलेबल है, पीपीटी भी है, सब है।
कहाँ पे सर? LMS में?
एलएमएस से भी जा सकते हो,
गूगल
एलएमएस पे
ड्राइव
लिंक है, मैंने बताया था, और गूगल ड्राइव की लिंक भी है। एलएमएस पे
गूगल
अगर जाओगे तो वहां पे लिखा हुआ है वीडियो लेक्चर, लाइव वीडियो लेक्चर लिंक, और पीपीटी एंड एक्सपीएस फाइल फॉर एमईई बैच, स्टार्टिंग पेज पे ही है, आपको दिख जाएगा।
ME बैच, ओके।
हाँ, एमईई बैच।
और
ठीक है,
गूगल ड्राइव में
मैकेनिक।
PPT?
हाँ जी,
गूगल ड्राइव PPT लिंक सर दे देंगे?
वही है, सेम है उसमें। पिछले 3 क्लास से मैं दे रहा हूँ, फिर कोई शेयर कर देगा। अभी कोई चैट बॉक्स में भाई
सर मैंने ग्रुप में सर कितनी बार शेयर कर दिया।
हाँ, वही अब क्या कर सकते हैं अभी। ओके, तो
ओके सर।
ठीक है, आप एलएमएस पे जाओ तो सही, एलएमएस बनाया इसलिए है। ठीक है, एलएमएस का
ठीक।
पर्पस ही फेल होगा अगर आपको पर्सनली चीजें डिलीवर करनी पड़ रही है, तो फिर एलएमएस का पर्पस क्या है फिर? ओके और पिछली 3 क्लास से वो लिंक शेयर कर ही रहे हैं हम, आप एक्सप्लोर नहीं करोगे तो फिर कैसे इंजीनियरिंग कर पाओगे। हाँ कुछ नए बच्चे भी आए हैं यहाँ पर, है ना। तो दिस इज माय नंबर, वैसे तो काफी लोगों के पास है। तो आपका जो भी, आप मुझे इस पे एक व्हाट्सएप मैसेज डाल दीजिए, और आपका जितना भी पार्ट मिसिंग है फिर हम देख लेंगे उसको कैसे कवर करना है। ठीक है, संडे सैटरडे संडे क्या फ्री टाइम है, हम कैसे उसको कवर कर सकते हैं। तो ये नंबर नोट कर लो और उस पर मैसेज कर देना। वैसे तो सारा रिकॉर्डिंग अवेलेबल है, बट स्टिल इफ समवन वांट्स की लाइव इंटरेक्शन हो तो मैसेज कर दो। कल 2 बच्चों के फोन आए थे। ठीक है। Okay, so I have taken a very simple circuit, resistance R1 and R2, and a capacitor C with a value C is connected in parallel to R1. Okay, now let's say that frequency F is 0. Okay, this is a source which can produce DC as well as AC voltages. So now let use this voltage source for producing DC voltage. So it is a producing a DC voltage with magnitude V. Frequency will be 0. Okay, and since the frequency is 0, if you calculate the reactance of this circuit, so it will be infinite. Infinite means open circuit. So this will be the equivalent circuit. Open circuit capacitance means it is not the part of this circuit, and the value of I will be V divided by R1 plus R2. Okay. Now this F is a very large value. F is a very large value, very close to infinity. Okay, one thousands of kilo ohm like this. So if you calculate reactance now, XC, प्लीज म्यूट कर लीजिए, कौन है, डिस्टरबेंस आ रहा है। जब भी कोई डाउट हो तो प्लीज आप अपने आप को अनम्यूट करके पूछ सकते हैं। Okay, so reactance is 1 upon 2 pi fc. So when f is very large value, okay, when f approaches to infinity, xc approaches to 0. 0 means a single wire. Okay, yesterday itself I have told you that whenever resistance or reactance is 0, it means that we have to use a single wire in place of that element. Okay, so now this capacitance is replaced by a simple wire. So this point A and B are connected by a wire. So now resistance R1 is shorted. Shorted means now there is no use of resistance R1 in the circuit. Current will start from this point. It will see that this is a low resistance path, so it will flow across this path, and then it will flow across this R2 and again back to the terminal. So like this will be the path in green in color. So current will not flow across R2. So I have replaced R2, sorry, R1. So this is the now this will be the equivalent circuit, and now in this case I will be equal to V in by R2. Okay, so this is the difference. Okay, so even though capacitance was there in the circuit, but the characteristics of the capacitance depends on the frequency of operation. If frequency is 0, you can ignore the capacitance. If frequency is very high, you have to replace it via short circuit. And for intermediate value, you have to calculate XC accordingly, and then you have to calculate the parallel value of reactance, and then add it to R2. Like this you have to do. Okay, so now coming to our diode, this is the device of interest. Okay, so uh, uh, till now we were operating it on DC voltage. Okay, so this is the equivalent circuit. It exhibits some capacitances CT and CD. We will see what is meant by CD and CT. So it exhibits two capacitances, but for DC signal F is 0, and if you calculate reactance CT and for CT and CD, it will be infinite. So for DC signal, you don't have to consider any capacitances. Simple a PN junction diode, and it can be replaced by this kind of circuit. If you are using piecewise linear model, so you can use this circuit RAV like this. But now if you are providing providing a signal with some particular frequency, okay, if you have provided AC signal, let's imagine that you have provided a sine wave, with some frequency f. Then this capacitor will come into picture. Okay, because now you cannot simply ignore them. It will also affect this overall resistance RAV value. Okay, so first we will define capacitance CT. Capacitance CT, it is defined as transition capacitance or barrier capacitance or depletion capacitance. Okay, so T, this T is subscripts is for the word transition. So mainly this is the main word. These are the Elias word, barrier capacitance or depletion capacitance. So CT is the capacitance in reverse bias. Okay, this is your PN junction diode. This is the depletion region, and this is P region, N region, and this area is depletion region. Okay, free free from the free of charge carriers. And N type, this N type will region will have some free electrons, and this P type region will have some free holes, like this. So you can imagine it as a parallel plate capacitor with dielectric in between. Okay, dielectric means a layer between the two conducting plates. Okay, a insulator layer between two conducting plates. So it is a kind of an insulator layer free from the charge carrier. Okay, and if you increase the reverse bias, what will happen? If you increase the reverse bias, the width of this depletion region will increase. Okay, simple, it will increase. So the meaning to say that the distance between this parallel plate capacitors is being increased. Okay, so whenever your diode is in reverse bias, it exhibits a capacitance because of this phenomena. Okay, two charging plus minus two opposite charges, and between them there is an insulating layer, and we define that capacitance as CT. Okay, we will not derive this, we will not get into the derivation. This is beyond the scope of this subject. So just you have to remember this formula. CT is given by C of 0 divided by 1 plus mod of VR by Vk, whole raised to power n. So C0 is the capacitance under no bias condition. Okay, no bias condition means simply you have not given any, you have not connected any external voltage source, and then you are measuring the capacitance. So the value is C naught. Now, if you apply a reverse bias VR, this is the VR. This is P type. This is N type, and this is VR. So VR is that value, reverse bias potential, magnitude of this external applied source. Vk is the knee voltage, and N, the value of N, it depends on manufacturing process. Generally, it is 1/3 or 1/2. Okay, so in Boylsted, it is
What is N?
N is N depends on manufacturing process.
Yeah, but it's just a constant.
Constant,
It does
yeah.
not have a name.
No, it will be either it is 1/3 or 1/2 for silicon.
Okay.
It can have any other value as well, but okay, yeah, either 1/3 or 1/2 will be given to you. So there is a very exhaustive derivation for this, but that is beyond the scope. So we will ignore that derivation.
Excuse me, sir.
हाँ जी.
सर ये जो ऊपर जो आपने डायग्राम बनाया है जो डायोड को वो दो कैपेसिटर्स इन पैरेलल हैं, ऊपर वाला वही C नॉट है अंडर नो बायस
CD है, उस पे भी आ रहे हैं, C of D है.
अच्छा ठीक है.
Okay, and whenever your diode is in reverse bias, this will be the equivalent circuit. A capacitor. Let me draw it on a fresh page. So if your diode is in reverse bias, if this is the case, so you will consider it like this. C of T. You will ignore CD. CD पे भी आते हैं. You will only consider CT. And if it is given that you have to use a piecewise linear model, then equivalent circuit will be okay. नहीं, ये तो reverse bias में, यहाँ तो कुछ होगा नहीं. तो reverse bias में इस तरह से करना है, CD को ignore करना है. CD forward bias में होता है. ठीक है? Simple, very simple circuit and very simple formula. So you can see that if you will increase VR, what will happen? VR को increase करोगे तो क्या होगा? Denominator will
increase.
Okay, denominator will increase, and the value of CT will decrease. Okay,
Decrease.
The simple reason is that if you increase VR, the width of the depletion layer will increase. Okay, width of the depletion layer increases means number of free charge carriers in P region and N region is decreasing, depleting. Okay, so it is obvious that if the free charge carriers, if Q are free charge carrier, if Q is decreasing, so obviously the value of CT will also decrease. And you can imagine, okay, you can use this formula also. C is epsilon naught A by D. So if this D is increasing, the distance between these two plates are increasing and the value of C will decrease. Okay, so you can uh, correlate this two things. The meaning is same. So if you increase VR, CT will decrease. Okay, we will see the graph also shortly. We will see the graph that is describing this relation between CT and VR. Next, we have diffusion capacitance that is defined for forward bias, and in this case, this will be your equivalent circuit CD. Now you will ignore CT. Okay, and since you are operating your diode in forward bias region, so now you have to use either piecewise linear model or simplified model or ideal model, whatever is mentioned in the question. So if piecewise linear model is given, let's say that this is connected to uh, voltage V, external resistance R, and this is operating at frequency F. Okay, वैसे ही आपको दिया नहीं जाएगा, जस्ट मैं समझाने के लिए बता रहा हूँ. एसी एनालिसिस हमारे कोर्स में नहीं है, फिर भी जस्ट नॉलेज के लिए. तो अगर इस तरह का कोई सर्किट है, तो आप व्हाट यू कैन डू, you can use piecewise linear model. So in this, you have to use VK followed by RAV, and in parallel you have a diffusion capacitance CD. Now this will be the equivalent circuit, and this is R external.
So forward bias.
Sir, can you explain again, sir, what is diffusion capacitance?
Diffusion capacitance, in this previous slide, I have told you that diode exhibits two capacitance. First is CT, second is CD. This is C of D. Okay. So CT is defined for reverse bias whenever your diode is in reverse bias, and CD is defined when your diode is in forward bias.
Oh,
They are independent thing. Okay. So now you will not calculate CT you will not calculate because it is given that your diode is in forward bias. And formula for CD is, this is the formula. Again, we will be ignoring the derivation because this is the beyond the scope of this subject. So CD is defined as tau T, this is tau subscript T divided by VK multiplied by ID. Okay, so ID you can calculate by the Shockley equation. Okay, VK, you know, VK is the value of V voltage. This is the new parameter tau T. So this is defined as minority carrier lifetime. Okay, now let us see what is the meaning of this minority carrier lifetime. So if this is your PN junction diode, this is P side having holes, and this is N side having some free electrons, and in between you have depletion region like this. Free charge carriers are not present in this depletion region, so this is depletion region. Okay, now you forward bias this diode, you connect P type terminal, P type region to positive, N type region to negative like this. So now what will happen? Few holes will flow from P region to N region. So let me draw this with red in color. So these are the holes. Holes with red in color have traveled from P region to N region. Similarly, some electrons will travel from N region to P region. Okay, so this red in color, the red color minus sign in p-type region is representing free electron that has traveled from n to p side. Okay, so this will continue, and because of this, some current will flow like this. Okay, now this holes, okay, again repeating, this holes, they are minority carriers in n-type region. Okay, they were majority in p-type region. They have traveled to n-type region and they are now minority. It is like Indian got shifted to Pakistan. So Indians are majority in our own country. Okay, and then when we will be there in Pakistan, we will be like a minority. So this is the case. And similarly, this electrons, they were majority in n-type region, and and the moment they enter in the p-type region, they become now minority. Okay, so they will remain in the p-type region for some time t. Okay, similarly, these holes will be present in this n-type region for some time, again for some time t, let's say t prime. Okay, now what will happen, because there are many electrons available in n side. Okay, talking about n side, okay, we have, let's say we have thousands and hundreds and thousands of electron, and one or two holes that got entered. So since there are large amount of electron present, they will capture the hole. Opposite charges attract each other, so this holes will be attracted by some electrons. Okay, meaning to say, असल में क्या होगा, ये holes किसी bond में form हो जाएंगे. Similarly, this free electron will be attracted by some holes. Okay, so after losing all of its kinetic energy, it will be in the bonded form. So the amount of time t, we measure the time t the moment it entered and it was in free state. Okay, ये आपका यहाँ पे एंटर किया और कितने टाइम t तक फ्री स्टेट में रहा और उसके बाद कंबाइन हो गया. तो ये t टाइम एवरेज हम कैलकुलेट करते हैं. वी कैलकुलेट एवरेज टाइम, okay, by some experiment. So that time is defined as minority carrier lifetime. Okay, so your diffusion capacitance CD is directly proportional to minority carrier lifetime. जितने ज्यादा टाइम तक वो फ्री रहेंगे, CD उतना ज्यादा रहेगा. ठीक है, that is the very basic concept. And jitna zyada value of id hoga, you can see that CD is also directly proportional to id. So more value of id means more amount of charge is being pumped into the system, into this device. So more value of q. Okay, id is what? Id is dq by dt. So more value of id, more value of q, more value of c. Simple. Okay, so again you have to remember this formula. We will not be deriving this. Okay, so this is the graph, figure 1.33, taken from Boylsted book. It is representing transition and diffusion capacitance applied bias for a silicon diode. So this is the zero. This is the origin. This region is representing forward bias, positive region, positive V axis, and the region on the left is representing reverse bias. Okay, so you can see that this, when I am moving from 0 to left hand side, meaning to say that I am increasing the value of VR. This is the formula. When I am increasing my VR, CT will decrease. Okay, and at 0, what will be the value? What will be this value? This will be C0. Simple. You can see from this formula. When this VR is 0, this whole term is 0, and the value of CT is 0. Capacitance under no bias condition. So when VR is 0, the value of CT is 0. So this point when V is 0, the value of capacitance is C0. And when you are increasing the reverse bias, CT is decreasing like this. So kind of exponential graph. And in forward bias, when you are increasing the V, when you are increasing the magnitude of this V, so as a result, I is also increasing. And when I is increasing, CD will also increase. Okay, so this is the exponential rise, because ID is e raised to power VD by eta VT. So the ID is an exponential relationship. So CD will also be the kind of exponential relationship. So in exponentially increasing. So V increases, CD also increases.
So can we say it increases because depletion region decreases in width?
Many factors are there. Depletion region decreases, ID increases, tau T also decreases. Okay, tau T
Tau
also
T also
decreases.
decreases with time.
Yes,
Tau T also decreases with
tau
time.
T
but
also decreases. Tau T decreases, ID increases, width
So
of the
but
depletion
tau T
region.
अगर decrease होगा तो CD कम नहीं हो जाएगा?
ID
Direct proportional. अगर tau T decrease होगा
no tau T हाँ tau T decrease होगा तो कम होगा, but overall this is decreasing.
overall increase है but in general
No
I'm saying
sorry tau T increase होगा ना, ज्यादा टाइम तक फ्री स्टेट में रहेंगे, ज्यादा एनर्जी उनके पास हो जाएगी.
एनर्जी ज्यादा
If
होगा
I
या
am
फिर टोटल नंबर ऑफ चार्जेस ही कम हो जाएंगे मतलब
no
डेंसिटी वाइज.
no you are interpreting it wrong way. If I increase this V, okay, so the holes traveling from P region to N region will have a higher amount of kinetic energy, so it will be in free state for a larger amount of time.
हाँ
वो काइनेटिक एनर्जी लेके एन रीजन में जा रहा है. अगर काइनेटिक एनर्जी कम है तो तुरंत वो मोशन की वजह से लूज करके बॉन्ड बना लेगा. अब ये मैंने V इंक्रीज कर दिया तो ज्यादा एनर्जी है तो ज्यादा टाइम तक वो ब्राउनियन मोशन या रैंडम मोशन में रहेगा. तो tau T is increasing, डिक्रीज नहीं हो रहा है.
ठीक गॉट.
Okay, ID is also increasing and W is decreasing. So all these cumulative three factor is contributing in increase of this CD. Okay, तो इससे ज्यादा हमें डिस्कस करना नहीं है डायोड कैपेसिटेंस के बारे में. This is the information that is included in your syllabus. That's it. Okay, so next topic is reverse recovery time. Okay, what is the time? 11:49. We have plenty of time. So for that, I have to draw PN junction diode again. So suppose this is our PN junction diode. Again, I am drawing the same structure and P region, N region, and this is the depletion region. And I have forward biased it like this. Some resistance is there, and I have value of IF forward. So the notation is I forward. Okay, so you know that I is dq by dt, means some amount of charge is flowing per unit time, and that amount is constant. Okay, that is why you are getting a constant value of I. So let us imagine that, just I am taking random values for explanation. Let us imagine that 100 holes are traveling from P region to N region because of this V external, and at the same time 100 electrons will travel from N region to P region. Okay, so we have holes traveling from P to N region, and we have electron traveling from N region to P region, and because of this we have some I forward. So dqh by dt plus dqe by dt, and both are, because of both the charge flow, we have current in the same direction. Okay, so I can, to avoid confusion, I can put this under mod. Both are positive quantity, both are contributing in positive value of I forward. Okay, got this thing. So T, let's say in 100 holes and 100 electrons are crossing this junction and flowing across this loop in T unit of time. Okay, now immediately, let's say at time t1, this is time axis, I am having some value of I forward that depends on this external circuit V by R. So I am having some value of I, and at this point t1, I instantly reverse the polarity of this external voltage source. So reversing polarity means now I have this minus connected to P side plus connected to N side, minus plus V. This is at T1. Okay. So now what will happen if your diode, if you consider that this diode is ideal? So this was the forward bias current. This was forward bias current in yellow color. This value can be, you can define this V by R approximately. Okay. And the moment you reverse the polarity of the external voltage, current goes to zero, like this, zero. And then it is zero. Okay. But this is not the actual case. Whenever you reverse the external voltage supply, your current is not zero at the same instant. This is the reason whenever you turn off your LED, you have noticed that whenever you turn the supply of LED, it glows for some time. It glows for some time. The reason is that the current is not zero. Now what is happening? Okay, so now the moment you have reversed this external voltage supply, you have 100 holes in N region, and you have 100 electrons in P region. Now this 100 holes are minority charge carrier in N region, and this 100 electrons are minority charge carrier in P region. Okay. Now because of this, there will be two electric field. One was already there, E internal, and because of this you have E external. So this two electric field will force these holes to move back again in P region, and this 100 electrons to move back again in N region. Okay. Initially they were in free state, and because of this electric field, they will be forced back again into P region, and this electron will be forced back again in N region. Okay. So now again there will be, now you can see after, let me draw it on fresh field. So when V supply is reversed, okay, 100 holes will flow from N to P region now, and similarly 100 electron will flow from P to N region. Okay, this is the case. Okay, now I am not drawing mentioning the other charge carriers. Just this is P region, this is N region. We have, let's say, 100 of holes here and 100 of electron in P region, and they will, now this electron will flow from P region to N region like this, and this holes will flow from N region to P region. So what will be the direction of current? The direction of current will be now from N side to P side, the direction of holes. This will be the direction of current. And what will be the magnitude of this current? Okay, so you define this ID. This I forward was defined as dq by dt like this, and this dq by dt, this q is 100 holes and 100 electrons. So when they are traveling in reverse direction, again I will be dq by dt holes plus dqe by dt. But since now they are moving in reverse direction, I can put a minus sign here. Okay, so the magnitude will remain same. The magnitude of the current remains same. Direction reverses. So this is what this graph is representing. At the moment, whenever you are reversing the external supply, the direction of current is reverse. Now this is current axis, this is positive, this is negative. So same magnitude of current, but now in reverse direction. And TS amount, this is called storage time. TS is called storage time. The time taken by this minority charge carrier, this holes and this electron, to move back again to their respective region. So this is called storage time. And after that, okay, immediately the things cannot move to zero. then initially things will move to 0. This is again an exponential curve. You have studied the transient characteristics in while your JE preparation. So you know that whenever capacitance is involved, now it will be having some transition capacitance, and this kind of characteristics is there: charging, discharging, charging, discharging, this kind of thing. This device is now losing its charge. This current will now move in this fashion. It will move to 0. So this is called T subscript T, transition time. Transition time. And T off time means when the value of ID will be 0. This is TRR. T off is also defined as T reverse recovery time. This is what reverse recovery mean. T off, your diode is off when the value of I is 0. So reverse recovery time is the sum of TS plus TT. T storage time plus T transition time. Okay. So in ideal case, whenever you reverse the polarity of your external voltage, immediately the value of current is 0. But this is not the case. You are using actual device, so it will take some time to get off. Okay, so you have to give this much. You have to wait for this much amount of time to again switch this back. ठीक है, बहुत छोटा सा फंडा है, बॉलस्टेड में एक पेज का कॉन्सेप्ट दिया है. इसमें कोई डाउट है तो पूछो.
Sir, what was storage time?
Storage time, this 100 hole will take some amount of time from traveling from N to P region, and this electron in P region will take some amount of time to travel back to P region to N region. So कुछ टाइम के लिए कांस्टेंट रहेगा. This dq by dt will be constant for some time, और उसके बाद फिर धीरे धीरे सारे चार्ज डिप्लीट होते जाएंगे. एकदम से तो सारे गायब नहीं हो जाएंगे ना.
Okay.
कोई 1 सेकंड में कंबाइन होगा, कोई 10 सेकंड में होगा, तो इतने टाइम तक तो वो वैल्यू कांस्टेंट रहेगा. करंट की मैग्नीट्यूड कांस्टेंट है. उसके
Yes,
बाद
sir.
कुछ चार्जेस रह जाएंगे. तो लेट्स से 50 चार्जेस रह गए, तो कोई 1 सेकंड में कंबाइन होता है, कोई 2 सेकंड लेता है, तो वो धीरे धीरे मैग्नीट्यूड कम होते जाए ऐसे.
सर
लाइक
Yes, sir.
सर सर ये जो एट T1 पे जो I रिवर्स है, दैट विल बी इक्वल टू द मैग्नीट्यूड जो I फॉरवर्ड था. लाइक उस टाइम ड्यूरेशन के लिए क्या करंट का मैग्नीट्यूड उतना ही होगा?
इफ दिस इज सेम, वो भी अगेन डिफाइन करेगा. सपोज दिस इज द केस. ओके, यहां मैंने वो बना दिया. इफ V external is V1 in forward bias, so I will be equal to V by R approximately. Okay, and if V external is minus V2 in reverse bias, so I will become, this is V1 V2 by R. क्योंकि इलेक्ट्रिक फील्ड जो जनरेट होगा वो आपका अप्लाइड वोल्टेज पे डिपेंड करेगा. तो इवन यहाँ पे 100 फ्री होल्स है, यहाँ 100 फ्री इलेक्ट्रॉन्स है. आप उसको इलेक्ट्रिक फील्ड अगर कम दे रहे हो तो कम रेट से ट्रेवल करेगा, ज्यादा दे रहे हो तो ज्यादा रेट से ट्रेवल करेगा. दिस इज द फंडा. अरे भाई कौन है ये? कौन था? कौन था भाई, नाम बता दो.
Sir, KCG.
ओके, लगता है मन से इंजीनियरिंग करने नहीं आया, मम्मी पापा ने जबरदस्ती भेजा है. तो बहाने ढूंढ रहा है यहाँ से जाने के. एनीवेज, दिस काइंड ऑफ बिहेवियर क्या कर सकते हैं. चलो, तो ठीक है. आपका जो क्वेश्चन था डिपेंड करेगा V पे. इफ V फॉरवर्ड बायस, V रिवर्स बायस आर सेम, देन द मैग्नीट्यूड विल बी सेम.
ओके सर.
Otherwise that depend on V, because this electric field is depending on the value.
ठीक है सर. थैंक यू सर.
Any
Okay, sir.
more questions?
Thank you,
सर
sir.
ट्रांजिशन टाइम भी बता दो एक बार.
Transition time, ये
यस.
वाला. Okay. Pn with some holes and some electrons. So I have defined that they were 100. So oh, म्यूट करना पड़ेगा मुझे। ओके, खैर वो तो मेल आईडी से लिंक से ट्रैक हो जाएगा, एक्सेल फाइल बनता है। Okay, so initially this amount free electrons and free holes is very large, so you will have a constant value of dq by dt. Okay, this was the point when you reverse bias this diode, so this dq by dt will be constant. So let's say this is I axis, एक मिनट, इस तरह का था ये I forward और इस तरह से, so this is I forward, this is I reverse, so that will be again depend on V by R. Okay, and it is not necessary that IF is equal to IR. That depend entirely on V. If this V in forward bias and reverse bias are equal, then it will be, then the value of IF and IR are equal. Okay, okay. So now coming back to this 100. Initially we have this 100 value is large. Okay, and we will have I equal to dq by dt, a constant value for some time. So this time is known as transition time. ट्रांजिशन टाइम वो अपने अपने घर वापस जाने का टाइम है, जितने n नंबर ऑफ होल्स अपने घर वापस जा रहे हैं और ये इलेक्ट्रॉन्स अपने n रीजन में वापस जा रहे हैं। ठीक है, तो वो टाइम कुछ ले लिया हमने, उसको t डिफाइन कर दिया ट्रांजिशन टाइम। ओके, तो अब ऐसा तो है नहीं कि ये सारे इलेक्ट्रॉन्स और होल एक ही साथ जाएंगे। ठीक है, dq by dt जो मैंने बोला दिस इज कांस्टेंट रेट। ओके, सो और एक और चीज है माइनॉरिटी कैरियर लाइफ टाइम, दूसरी चीज है माइनॉरिटी कैरियर लाइफ टाइम। सो हर चार्ज के लिए ये अलग अलग होता है। हम एवरेज जो टाउ टी हमने डिफाइन किया था दैट वाज एवरेज। ओके, फॉर एग्जांपल अगर इस क्लास में 100 बच्चे हैं और उन्हें 100 मीटर रेस में अगर हम पार्टिसिपेट करने का कहें तो हर स्टूडेंट का एक अलग अलग टाइम होगा उसे कवर करने का, बट हम एक एवरेज टाइम डिफाइन कर सकते हैं, टाइम टेकन बाय ऑल द स्टूडेंट डिवाइडेड बाय टोटल नंबर ऑफ स्टूडेंट्स। सो वी डिफाइन दिस एज एवरेज टाउ टी एज एवरेज माइनॉरिटी लाइफ टाइम कैरियर। सो सिमिलरली ऐसा तो है नहीं कि 50 के 50 100 के 100 एक साथ ही गायब हो जाएंगे। ठीक है, कोई अपने रीजन में आने के बाद कुछ फ्री स्टेट में रहेगा तो वो ये लूप कंप्लीट कर सकता है। ओके, लेट्स से 100 यहाँ पे आ गए, बट 50 या 60 में अभी भी फ्री एनर्जी है, तो वो ये लूप से बाहर आ जाएंगे। उसमें इतनी काइनेटिक एनर्जी होगी कि ये लूप क्रॉस कर लेंगे और ये लूप पूरा करेंगे। ओके, सो इस पॉइंट के बाद सारे अपने, ये पॉइंट ये है कि सारे होल्स अपने रीजन में आ गए और सारे इलेक्ट्रॉन्स अपने रीजन में आ गए, बट स्टिल अब 100 में से मान लीजिए 50 के पास स्टिल काइनेटिक एनर्जी है जो ये वायर को क्रॉस करके ऐसे जा सकता है। दिस नेगेटिव टर्मिनल विल अट्रैक्ट दिस होल्स, तो अभी भी उसके पास इतनी काइनेटिक एनर्जी है कि वो बॉन्ड नहीं फॉर्म करेगा, वो क्रॉस कर लेगा। सो बिकॉज ऑफ दिस यू विल स्टिल हैव सम अमाउंट ऑफ करंट। ओके, सो ये कांस्टेंट रहेगा। देखिए एक लूप पूरा हुआ तो नेक्स्ट लूप में 40 के पास काइनेटिक एनर्जी बचा तो करंट थोड़ा सा कम हो गया, फिर एक सेकंड लूप कंप्लीट हुआ तो 30 के पास कुछ काइनेटिक एनर्जी बचा। तो ऐसे करते करते वैल्यू 100 से 40 50 करते 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 एक टाइम ऐसा आएगा कि किसी भी फ्री होल्स के पास या और इलेक्ट्रॉन्स के पास काइनेटिक एनर्जी नहीं बचेगा। कब तक वो राउंड लगाएंगे, क्योंकि ये तो अपोज कर रहा है, ये जो कॉन्फ़िगरेशन है ये तो मूवमेंट को अपोज कर रहा है। सो इवेंचुअली इनिशियली 100 से स्टार्ट किया, देन 50 40 30 10 20 90s सॉरी रिवर्स में जाना था 10 5 0 तो ये कैरेक्टरिस्टिक्स एक्सपोनेंशियल होगा तो ये हम कहते हैं ट्रांजिशन टाइम टी 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 सॉरी दिस इज अरे यार मैं दिस इज स्टोरेज टाइम ये होता है ऐसे बच्चा भी डिस्टर्ब करके जाता है पूरा फ्लो डिस्टर्ब हो जाता है एंड दिस इज ट्रांजिशन टाइम ओके जादू तो होगा नहीं एकदम कि 100 के 100 एक साथ गायब हो गए ठीक है ऐसा हो ही नहीं सकता 100 स्टूडेंट अगर रेस में पार्टिसिपेट कर रहे हैं तो सबके सब एक साथ बाउंड्री लाइन पे पहुंच गए तो बिकॉज ऑफ दैट डिफरेंसेस you will have this kind of characteristics so you define reverse recovery time means आपका डायोड जीरो स्टेट में कब जा रहा है वापस id जीरो कब हो रहा है उसके लिए that time is defined as reverse recovery time and you can see that it is sum of tt plus ts Ayush 1 minute yes Ayush
सर मुझे लाइक वो स्टार्टिंग लेक्चर की जो स्टार्टिंग में स्लाइड दिखाई थी उसमें कुछ डाउट था मुझे
ओके ये वाला
नहीं डायोड कैपेसिटर सॉरी जो सबसे पहली स्लाइड थी
ओके
यस सर सर इसमें हम वो फ्रीक्वेंसी वाली मतलब क्या बात ये फ्रीक्वेंसी और जो आपने समझाया था फॉर डीसी सिग्नल ये क्या चीज है
डीसी सिग्नल का फ्रीक्वेंसी क्या होता है
मतलब स्ट्रेट लाइन होती है तो
हाँ
इसलिए
स्ट्रेट लाइन मतलब फ्रीक्वेंसी मतलब वेरिएशन पर यूनिट टाइम
ठीक है
वेरिएशन पर यूनिट टाइम तो दिस इज 0 दिस इज 1 सेकंड तो कितनी बार ये प्लस माइनस हुआ लेट्स से 10 टाइम्स तो इसकी फ्रीक्वेंसी
Okay.
होगी 10 हर्ट्ज 10 साइकिल्स in
Yes,
1
sir.
second so 10 hertz so dc is not varying it is a constant line so frequency is 0
और से एक्सी क्या है हमारा
xc रिएक्टेंस जो हम कैलकुलेट करते हैं ये फॉर्मूला होता है xc इंडक्टेंस का xl ये रिएक्टेंस xl कुछ होता है 2 पाई fl ऐसा कुछ होता है ना रिएक्टेंस
ठीक है
वो चीज है तो अगर f is 0 if f is 0 so xc is infinite तभी तो हम कहते हैं capacitance does not allow to pass dc signal across it why the reason is that its reactance is infinite तो कोई भी इनफाइनाइट अगर इनफाइनाइट रेजिस्टेंस हो या इनफाइनाइट कैपेसिटेंस हो वो अपने अक्रॉस सिग्नल को पास नहीं होने देगा सो आपको याद होगा ये स्टेटमेंट
ओके
चलिए एक डाउट और ले लेते हैं टाइम भी खत्म हो रहा है आयुष विशेष यस विशेष
सर वही बोलना सर अगली क्लास का टाइम हो गया सर
हाँ थैंक यू ओके हैव अ नाइस डे सी यू ऑन
Thank you.
फ्राइडे